All right, number 31, again, solve the problem, and we're told that a lumberyard has fixed costs of $4,432.80 per day and variable costs of 85 cents per board foot produced. They tell us lumber sells for $2.05 per board foot, and they want us to find out how many board feet must be produced and sold daily to break even. Now, if you haven't watched video number 30, go ahead and take a look at question number 30, video 30, because I go into more in-depth explanation of what the break-even point is and how to find it. So I'm not going to do that in this video. I'm going to go right to this slide, and we're going to start finding the cost function and the revenue function, which are the two pieces that we need. We're going to then set those two things equal to each other so that we can figure out how many board feet we have to produce and sell daily. So if you haven't watched 30, go back, take a look at 30, and this will all make a lot more sense. If you have, then I think we're good to go. All right, so we know that we're going to go back and read the problem again, only now we're going to start identifying this information for the cost function and the revenue function so that we can fill in our missing boxes, and then we're going to set these two things equal to each other. So a lumber yard has fixed costs, all right, fixed costs of $4,432 per day. And again, if we go and look at our cost function, C of x equals mx plus b, we know b is representing the fixed costs. Well, the fixed costs are $4,432.80. All right, and we have variable costs of 85 cents per board foot produced. All right, variable costs is just another way of saying how much does it cost for every board foot that we produce. And again, here in our cost function, that information is represented by M, cost to produce each board foot. Well, that's 85 cents, so we'll put 0.85. And then X from the cost function is the number of board feet that we are going to be producing. Well, we don't know what that number is, right? That's what we're being asked. How many board feet must be produced? Well, we don't know just yet. That's what we're trying to find out, so we'll let that be X. All right, so we've got our cost function. Now let's go ahead and see if we can find what our revenue function is. Lumber sells for $2.05 per board foot. All right, well, if we look at our revenue function, R of x equals P times X, the P represents the price per board foot sold. Well, lumber sells for $2.05, so 2.05. And again, the X in the revenue function is the number of board feet sold. Well, we don't know how many board feet have been sold. That's what we're trying to find. So we'll let that be X. And again, the X is what we're trying to solve for in number 31. We're trying to find out how many board feet must be produced and sold daily to break even. Break even meaning the company, or in this case lumberyard, isn't making any money, but they're also not losing any money. All right, so we've got our cost function, we've got our revenue function. We know we have to set these things equal to each other, so let's go ahead and do that. So we'll have the 0.85x plus 4,432.8. And remember, right, if this is just a 0, we can go ahead and drop that. We don't have to put the 0.80. All right, equals, and now 2.05x. We want to solve for x, so let's see if we can get the x's on one side of this equation, this equal sign, and we can do that by subtracting 0.85x from both sides. All right, I'm going to move this up here, and when we do that, we end up with 4,432.8 equals, and 2.05 minus 0.85 should give us 1.2x, and we'll then divide by 1.2 so we can get x all by itself, and so x equals 3,694. So 3,694 board feet must be produced and sold daily in order to break even. Again, if they produce and sell less than 3,694 board feet, this lumberyard will be losing money. If they produce and sell more than 3,694 board feet per day, they'll be making money. But if they're looking to simply break even, this is the number of board feet they need to sell and produce daily.